Okay, we're talking about areas of a regular polygon. We're going to find the area of an equilateral triangle and then find areas of regular polygons. The center of a regular polygon is the center of a circumcised circle. So that means if we've got our shape, for example, like a rectangle, it is inside the circle. And the center is the center of that circle. It's like the shape is encompassed in it. The radius of a regular polygon is the radius of a circumscribed circle. So that means, like if we've got a pentagon, and we've got a circle around it, the radius goes from the center to the point, which would be on that circle. Okay. The distance from the center to the side of a regular polygon is called the apothum. So we've got the radius and we've got the apothum. So again, if we've got a pentagon, the center to the side is called the apothum. So who's ever got the apothum, that's what they're going to draw. They're going to draw some kind of shape with a point from the center to the side. A central angle of a regular polygon is an angle whose vertex is the center and whose sides contain two consecutive vertices of the polygon. The area of an equilateral triangle is 1/4 of the square of the sides times the square root of 3. So the area for an equilateral triangle is area equals 1/4 square root 3 s squared. There are other ways to figure out the area of an equilateral triangle, but this is in case you wouldn't know the height of that equilateral triangle. It makes it a little bit easier. Now, the most important part, our area of a regular polygon. Area of a regular polygon is 1/2 the apothum times perimeter. And NS is just the number of sides times the length of the sides. Okay. All right. We are not going to do example 1, justify it. I don't think you guys particularly want to do a proof. So we're going to look at A and B for example 2. This side is 7 centimeters, so we're just going to use that equation for area of an equilateral triangle, which is 1/4 square root 3 times side squared. And what is the side in this case? 7. So you're just going to put that in your calculator. What's another way to write 1/4 if we wanted to do it just in a decimal? 0.25. Then we times it by the square root of 3. And then we times that by 7 squared. And we get 21.21 centimeters squared.
Oh, if you don't put the parentheses around the side, it won't work.
Oh, is that what I did? Okay,
No,
let me try it again.
I'm asking.
I don't know. I'm going to try it. Times the square root of 3 times 7 squared. I get the same answer on my calculator.
Oh, I missed it.
I did that the first time I did it too. I didn't square the 7. Got to make sure you do that because it messes you up. So why don't you guys try B yourselves? It's 11. You're going to put it in. We know the equation is 1/4 square root 3 sides squared. So why don't you try B real quick on your own?
I'm doing. I'm trying to figure out the lowercase I just did not do
Let's go. 0.25 times square root. All right, guys, what did we get? So we did 0.25 times the square root of 3 times 11 squared, and you got 52.39. And that is feet squared. Good. Okay. So we got quite a few things to talk about for the next one. All right. We're given that the apothem, so we're going to call it little a, is 10 feet. And we know it's a pentagon. That's all we know. Okay. We know for the area of a regular polygon, we know that that is 1/2 apothem times perimeter. I did, because they're, again, just proofs. I'm just going to do example 4. Okay. What is the apothem? It's from the center to where? The side. So let's draw in the apothem. I'm going to label it 10. Okay. What do we need to know in order to find the perimeter? Sides. Okay, this is where it gets complicated. All right. We need to find this length right here at the bottom. We're going to create a right triangle. All right. So if I drew from the center to a corner, we call that a radius. Do you see that I've created a right triangle right here? Okay. What I want to know is this angle up here. Okay? This is where we get a little bit complicated. I'm going to find this whole angle and then divide it in half. And it's called the central angle. How many sides does this have? 5. We know that the interior angle of a circle always is what? 360, right? So we're going to do 360 divided by 5. 360 divided by 5 gives us what? You all have calculators. I need you to do 72. Okay, but 72 is the big length. I'm looking at, I'm going to draw it out. I want this little angle inside the calculator. So I don't want 72, I want what? If this whole thing is 72 and I want this little part, what am I going to do? Divide by 2. What's 72 divided by 2? 36. Okay, so this angle's 36 right here. I want to know this down here. What am I going to use to find that side? I've got an angle and a side, and I want to find another side. Yeah, Pythagorean. You can't use Pythagorean theorem because you'd have to have 2 out of the 3 sides. If we've got an angle and a side, we're going to use trig functions. What is 10 to 36? Opposite, adjacent, or hypotenuse? Adjacent. What is x? Opposite. Hypotenuse is always across from what? The 90. Okay. If I'm using adjacent and opposite, which trig function? Tan. Good. So I've got tan of 36 equals opposite over adjacent. I solve by multiplying both sides by 10. Okay. So I take out my handy dandy calculator. 10 tan 36 gives me 7.27, let's say. Let's round. Okay, now here's my question. Is that the whole side? It's what of the side? So how do I figure out what the length of the side is? Times it by 2. I get 14.54. Okay, I've got the length of the side. How would I figure out what the perimeter is? Times it by 5. So my perimeter is 72.7 feet. How do I find my area again? What's the formula? 1/2. What does A stand for again? Apothem. What's my apothem? 10 times what? The perimeter, which is 72.7. And we're finally done.
Hey, where'd the side come from?
Hold on one second. 72.7. And we get 363.5 feet squared. I know. Okay. Which one, Genesis? You didn't know where the side came from? I took what I found for x, and I knew that was this length right here. And so I doubled it, and that gave me the side. We're going to do way more of these, but I know this is confusing. Okay. The next one I'm going to do, I'm going to try to write the steps along the side. Okay. The next one is going to be slightly different because we don't have the apothem, we have the radius. Please put your phones away. I don't want to keep repeating myself. Okay. Let's talk about what we know about this piece. We know the radius is 12. What kind of shape is it? Hexagon. Okay? I like to write the area formula next to it because I like to remember what I need. I need area equals 1/2 the apothem and the perimeter. So I have to know what the apothem and perimeter is before I can do that formula. Okay. How would I draw in the radius? Yes. From the center.
Center to the side corner.
Corner, vertices. Yep. Vertices. Okay. That's all we know. All right. Step number 1. Let's draw in that right triangle. Okay. Let's talk about what we need to know. We're going to need to know the apothem, and we're going to need to know this length right here, and then we'll have to double it to find the side. Okay. I've only got the hypotenuse up there, right? What am I going to need? I'm going to need an angle. How am I going to find the angle? So we know the whole thing makes a circle, right? So we always do step 1, central angle. Okay? So we always take 360 divided by, how many sides does it have? 6. What's 360 divided by 6? Okay, but we don't want 60. Central angle then divide by what? By 2. So we get 30. Okay, now I'm going to draw this triangle bigger so I can see it. I know this is 30. And I want to find x